So hello students, let's start with the video solutions of full test 3. Okay. Yeah. So in question number 51, the correct IUPAC name for the following. So the compound is given and what we have to do, we have to find the correct IUPAC name of this molecule, right? Okay. So first what we have observed that this is the carbon chain, and here CN is a functional group and CHO is a functional group which is attached to the carbon chain, right? So first we have to look upon the priority. So priority. So here CN has more priority than the aldehyde group. So CN has greater priority than the CHO. Greater priority than the CHO group. Yeah. Than the CHO group. So what will happen? We have to include the CN in the parent carbon chain, right? So let's include it in the parent carbon chain. So like this will be the parent carbon chain, okay? And this and CHO group, this will be the substituents which is attached to the parent carbon chain, right? So let's start the numbering. What will be the numbering? The numbering will start from CN itself. So here 1, 2, 3, 4 and 5. Okay. So this will be the numbering. Now what are the substituents? Then we have to name the substituents. Here this group is a substituent, right? Yeah. So this will be the ethinyl group. This will be the ethinyl group, and this one is the formyl group. And this is the parent carbon chain. So accordingly, what will be the correct IUPAC name? At second position there is ethinyl group, right? At second position there is ethinyl group. At third position there is formyl group. Third position there is formyl group, and in the fourth carbon, there is a double bond. Okay. So 4 and the parent carbon chain is of 5 carbon atoms. Therefore, pent is used and nitrile. CN is there, so nitrile is used, right? So this will be the second one will be the correct option. Okay. Okay. So let's move on to the next question. Yeah. Question number 52. The number of unpaired electrons in 1s2, 2s2, 2p3 is. Okay. So the electronic configuration here is given. Electronic configuration is given and we have to find the number of unpaired electrons. So for finding the unpaired electrons, we first have to fill the electrons in the orbitals. So in 1s there are 2 electrons. So for 1s the 2 electrons are drawn. For 2s the 2 electrons are drawn, and for 2p the 3 electrons are drawn. So here we can see that there are 3 unpaired electrons. 3 unpaired electrons are there. Therefore, the correct answer will be 3 unpaired electrons. Okay, easy. In question number 53, for question number 53, the structure of XCO3. Okay, the structure of XCO3 is asked. So let's draw the structure of XCO3 first, like this. Okay, this will be the structure of XCO3. Also, there is one lone pair is present. Okay, one lone pair is present. So what happens that this type of molecule, the expected geometry, the geometry which will be expected by this molecule will be tetrahedral. Okay, tetrahedral. But what happens that because of the presence of the lone pair, the actual geometry of this molecule becomes pyramidal. Okay, it becomes pyramidal. So for the structure of XCO3, the correct answer, the correct geometry will be pyramidal. Why? Because of the lone pair of electrons which are present in the xenon atom. Okay. So the next question is, the method used to purify liquids having very high boiling points and those that decompose at or below the boiling point is. Okay, so for this question, what happens? Let's see the answer. Question number 54, right? So for question number 54, uh, the method used to purify liquids having very high boiling points. Okay, the liquids are having very high boiling points that decompose at or below their boiling point. So we have to identify the method which is used in this process. Okay, so see, when the pressure above a liquid is reduced, the vapor pressure decreases, which causes the liquid to boil at a lower temperature than its boiling point. Okay, as the pressure increases, the vapor pressure decreases. Okay, and when the vapor pressure decreases, the boiling point also, liquid boil at lower temperature, so the boiling point also decreases. Boiling point decreases. So this can be used to purify liquids at very high boiling points. So those liquids which are having very high boiling points, they can be used, this method can be used to decompose that. Why? Because the as the pressure is increased, then the boiling point will decrease, right? So the fourth option, which is distillation under reduced pressure, this will be the correct option, because as the pressure increases, the boiling point decreases, right? So the liquids which are having very high boiling points, so if we increase the pressure, then their boiling point automatically decreases. Okay. Question number 55. The correct order of solubility in water for helium, neon, argon, krypton, xenon is. We have to find the order of solubility. Okay. So for order of solubility, what we have to see? We have to see the molecular weight of the noble gas. Okay. As the molecular weight increases, the solubility of the element also increases. So among the noble gas elements, which element have the greatest molecular weight? So xenon has the greatest molecular weight, then krypton, then argon, then neon, and then helium. So I am talking about the molecular weight. Okay. So this same order will be followed for solubility also. So for solubility also, this order is followed. So option number 2 is the correct option. Okay. Question number 56. Which one is the wrong statement? So let's see for question number 56. Yeah. For question number 56, first highlight the point where it is written wrong. Okay. Otherwise, you will take the correct answer. Right? Which one is the wrong statement? So let's read the statement. Here, the uncertainty principle is delta E into delta T greater than equals to H by 4 pi. Yeah, this is the correct statement. Half-filled and fully filled orbitals have greater stability due to greater exchange energy, greater symmetry, and more balanced arrangement. This is also the correct statement. The third statement. Let's read the third statement. The energy of 2s orbital is less than the energy of 2p orbital in case of hydrogen atoms. Okay, so this is not the case. Let's explain the option 3 first. The statement 3 is incorrect. Okay, because in hydrogen like atoms, what happens that the energy of an electron depends on the principal quantum number. So we all agree upon this, right? For hydrogen like atoms, the energy of an electron depends upon which quantum number? The principal quantum number. Like for n equals to 2 level, both the 2p and 2s orbitals have the same energy. Okay. But here it is given the energy of 2p orbital is less than 2s orbital is less than that of 2p. But this is not the case in hydrogen atom, right? Both are equal and are of same energy. So the energy of 2s is similar to the energy of 2p. So option number 3 is the incorrect one, but the correct answer for this question, right? And option number 4, the de Broglie wavelength is given by lambda is equals to h by mu, where m is the mass of the particle and mu is the group velocity. Okay, it is v. V is the group velocity of the particle. So this option is also correct, which means okay, it is right. It is the right, which means it is incorrect solution. Okay. So for question number 57, let's move on to question number 57. Which of the following properties has a higher value for trans isomer as compared to the cis isomer of but2ene? So let's see the cis and trans isomer of but2ene first. Yeah. So, okay. Now tell me which is the trans isomer and which is the cis isomer for this compound. So here the MER at the same side. So this is the cis isomer and the MER opposite side. This is the trans isomer. So this is the identification mark for cis and trans isomer. Right. Now we have to find out that which of these properties, the trans one is greater than that of the cis one. So let's see. The dipole moment. The dipole moment of cis isomer is greater. Okay. So this will not be the correct option. The boiling point of cis isomer is also greater than the trans isomer. The solubility in H2O, solubility in water is also greater for cis isomer. But the melting point is the one which is greater for trans isomer than cis isomer. Okay. So what will be the answer? Melting point will be the answer. Melting point of trans isomer is greater than melting point of cis isomer. Okay. Yeah. So for question number 58, the hydrogen ion concentration in mole per decimeter cube in a 0.2 molar solution of a weak acid Ha is close to. Okay. We have to find out the H plus ion concentration, hydrogen ion concentration. We have to find out. Right. So, okay, find out. We for a conjugate acid base, which formula we can use? Ka into Kb. We know that Ka into Kb is equals to Kw. Kw, what is the value of Kw? It is 10 to the power minus 14. And we have to find the value of Ka. Okay, Kb is given. So for Ka, we can write that Kw divided by Kb. Okay. And Kw, the value for Kw is 10 to the power minus 14. And Kb value is given in the question as Kb value is given here 5 into 10 to the power minus 10. Okay. So put this on putting these values, we will get Ka is equals to 2 into 10 to the power minus 5. And for hydrogen ion concentration, the hydrogen ion concentration formula uses delta under root Ka into C. K we have find out as 2 into 10 to the power minus 5 and C we have find out as C is given in the question 0.2 molar. Okay, on putting these values, we will get 2 into 10 to the power minus 3. Okay, so option number 3 is the correct option here. Yeah. So move on to the next question. Question number 59. Okay. Cellulose is a polymer of. Cellulose is a polymer of, let's read the option, alpha D glucose straight chain, alpha D glucose branched, beta D glucose. Okay, this part is the option number C, and this is the option number, okay, this is option number 3 and this is option number 4. Okay, so cellulose is a polymer of alpha D glucose straight chain, alpha D glucose branched, beta D glucose straight chain and beta D glucose branched. So let's we can draw the structure of cellulose, right? So we can draw the structure of cellulose. This is the pyranose ring. Yeah, so here it is H. Here it is oxygen, and here like this we can draw. Okay. Yeah, here it is another molecule which is attached. Okay, this is cellulose has a large structure, so it can be regarded as an extended one. Okay, here like this, and let's put on the H and OH first. Here OH, H, H, and here it is OH. Here it is carbon. Here hydrogen OH. Okay, here it is OH. Okay, so let's consider this part. This is a beta D glucose. Okay, beta D glucose. So many beta D glucose structure combine together to form a cellulose structure, and here this type of linkage, what this type of linkage is called, it is uh, 1,4 linkage. Okay, 1,4 linkage, or say beta 1,4 linkage. This is the beta 1,4 linkage, and this type of structure is of, this is the structure of cellulose. This is the structure of cellulose. So like this we can draw, and many beta D glucose are joined in a straight chain. Like here I have written here it is N, which means that here one glucose molecule is there, beta D glucose, and another beta D glucose molecule is attached to the to this molecule. So a straight chain is there. Straight chain is there. So option number 3 will be correct. That a single molecule has beta D glucose and many straight chain atoms are there. Okay. These structures are attached to each other by straight chain. Question number 60. So for question number 60, two electrons occupying the same orbitals are distinguished by. So two electrons which occupy the same orbital, it can be distinguished by the spin quantum number, because we know that spin quantum number has the two values, which is of plus half and minus half. So we can say that it helps to distinguish between two electrons that occupy the same orbital. So spin quantum number will be the correct answer. Next is question number 61. Which of the following statement is incorrect? So find out the incorrect statement. The bond angle of pH4 plus is higher than that of pH3. Okay, this is the correct option. Tritium is the radioactive isotope of hydrogen. This is also the correct option. Ozone is not an allotropic form of oxygen. Ozone is not an allotropic form of oxygen. No, it is an allotropic form of oxygen. Therefore, it is the incorrect option. Okay, and the correct answer. See, ozone is an allotropic form of carbon, and allotropes are, what are allotropes? We know that allotropes are the different forms of same element in the same physical state. Okay, so therefore ozone is an allotrope of oxygen. But here in the question it is given that it is not an allotrope of oxygen. Therefore this will be the incorrect answer and the correct option, right? For question number 62, the following reaction P is obtained as the major product. Okay, here see RCOR, here it is R C double bond O R. Okay, it is a ketone. Then Grignard reagent is reacted. We get an intermediate which on hydrolysis gives a product P. Okay, so we have to find that P, what type of product is P, and what will be its reaction with the Lucas reagent. So we know that ketones on reaction with RMGX followed by hydrolysis produces a tertiary alcohol. Okay, so here P will be the tertiary alcohol, and we know that the tertiary alcohol, what it does, it provides instant turbidity with the Lucas reagent. Right, this is the distinguish, we can say that distinction between the types of alcohol, right? Primary, secondary, tertiary. The tertiary alcohol gives the turbidity instantly on reaction with Lucas reagent. In question number 63. So in question number 63, the correct order of bond order of ClO is. So different types of ClO bonds are given. So we have to find out the bond order. So first let's see the formula for bond order. So bond order we can find out by 1 plus number of pi bonds divided by number of sigma bonds. Okay. So for using the number of pi bonds and sigma bonds, we first have to know the structure of these compounds, right? ClO4 minus, ClO3 minus, ClO2 minus, and ClO minus. So let's first try to draw the structure for all of these. Okay, where is the space? Okay, we can draw here. So for ClO4 minus, see, this type of structure is drawn. Okay, ClO4 minus. So what will be its bond order? Its bond order will be number of pi bonds. How many pi bonds are there? 3 pi bonds are there, and number of sigma bonds, 4 sigma bonds are there. So its bond order comes out to be 1.75. Okay. The next is ClO3 minus. So for ClO3 minus also we will draw like this. Okay, this one will be the structure, and its bond order will be 1 plus number of pi bonds is 2 and number of sigma bonds is 3. So its bond order comes out to be 1.66. Next is ClO2 minus. So ClO2 minus here like this. Okay, and its bond order will be 1 plus, how many pi bonds are there? 1 pi bond and 2 sigma bond, that is 1.5. 1.5. Similarly for okay, we can draw here. Similarly for what is left, ClO minus. For ClO minus, this type of structure, and its bond order 1 plus, pi bonds are 0 and sigma bond is 1, that means 1. So from this we can find out all the bond order, and the order of their bond order will be ClO4 will be the highest bond order, then ClO3 minus, then ClO2 minus, and then ClO minus. So option number 1 will be the correct option, right? So let's move on to the next question. Question number 64 states the enthalpy change for the transition of liquid water to steam is vaporization. Vaporization is given 37.3 kilojoule per mole at 373 Kelvin. The entropy change for the processes. We have to find the entropy change. That means delta S of vaporization we have to find. So we know that delta S vaporization equals to delta H vaporization by temperature. So delta H vaporization is given as 37.3 kilojoule and temperature is given to be 373 Kelvin. So on putting it directly, we will get the answer 0.1 kilojoule per mole, but we have to find it in joule per mole. Okay, so for joule per mole it is 100 joule per mole. Option number 2. Okay. For question number 65, okay, when CH3Cl and AlCl3 are used in Friedel-Crafts reaction, the electrophile is, okay, so for CHCl3 and AlCl3, so when these both are reacted, what we will get, okay, CH3Cl is there, right? Sorry. Okay, here it is CH3Cl. So what happens that this Cl molecule is transferred to this AlCl3, and what we will get CH3 plus and AlCl4 minus. Okay, so it is asking what will be the electrophile. So electrophile, what are electrophile? Electrophile are positive species, right? So this is an electrophile. CH3 plus is an electrophile. Okay, so option number 3 is the correct option. For the next question, question number 66, the specific conductivity of the 0.1 normal KCl solution is 0.0129 ohm inverse centimeter inverse. The resistance of the solution in the cell is 100. The cell constant will be, we are asked the cell constant. Okay, cell constant. So let's put on this in the equation. So we know that the specific conductivity kappa, what is kappa? Kappa is 1 by r into cell constant. So specific conductivity is equals to 1 by r into cell constant, and we know that cell constant is equals to kappa into r. So here kappa is given, the value of kappa is given to be 0.0129 and the value of r given is 100. So answer comes out to be 1.29. Okay, so 1.29 is the correct option. Now question number 67. What is the chemical formula for pyrophosphoric acid? So pyrophosphoric acid, the chemical formula is H4P2O7. H4P2O7 is the correct formula for pyrophosphoric acid. Okay, so H4P2O7, option number 3. Others, what are the names of others is also given. HPO3N, this is the name for polymetaphosphoric acid. Okay, next is H4P2O6. H4P2O6, this name is hypophosphoric acid, and pyrophosphoric acid is H4P2O7, and H4P2O5, this is the pyrophosphorus acid. Okay, yeah, so we have reached to question number 67. So I hope you all are doing well in chemistry, right? Because it is a very scoring subject. If you are well aware of these facts and well aware of the numericals, of the formulas for physical chemistry, and you have practiced enough formulas and done numericals, then it is easy for you to score a good marks in chemistry, which will automatically help in your uh, in enhancing your marks for the NEET exam, right? So, which of the following, question number 68 says, which of the following sets of compounds cannot be distinguished using the iodoform test? Okay, so the iodoform test involves the reaction of compound with iodine in the presence of NaOH to give a yellow precipitate. Okay, so we know that iodoform test gives a yellow precipitate, right? So, which of the following sets of compounds cannot be distinguished using iodoform test? So, option number 2, ethanol and pentanone cannot be distinguished. Okay. Uh, why it is so? Because the ethanol, question number 68. Okay. Uh, Ethanol and pentanone. Pentanone is a methyl ketone. Pentanone is a methyl ketone, and ethanol. So these two are the compounds which cannot be distinguished by the iodoform test. Question number 69. Question number 69 says AlF3 is soluble in HF only in the presence of KF due to the formation of, okay, AlF3 is soluble in HF due to the formation of. So we have to find out which or among all these which is formed in the reaction. The solubility of aluminum fluoride and hydrofluoric acid only in the presence of potassium fluoride suggests the formation of a complex ion. Okay, a complex ion is formed by the reaction of AlF3 and HF. So it forms a complex ion AlF6 3 minus. Okay, AlF6 3 minus is formed in the as the complex ion. Potassium fluoride assists in this process by providing the fluoride ions. So fluoride ions are provided to this complex ion, which can then react with AlF3 to form the complex ion. So option number 2 is the correct option. Okay, K3AlF6. Question number 70. What does question number 70 says? A solution contains 10 milliliter of 0.1 normal NaOH and 10 milliliter of 0.05 normal H2SO4. The pH of this solution is, we have to find the pH of the solution. So in question number 70, the number of milli equivalents of NaOH. What are the number of milli equivalents? It is number of volume given into concentration into normality. Okay, so the milli equivalents comes out to be 1. For H2SO4, the milli equivalent comes out to be 0.5, and the milli equivalent, what happens that the milli equivalent of H2SO4 will neutralize the milli equivalent of NaOH. So what we will get, the number of unreacted milli equivalent of NaOH is left unreacted, which is 1 minus 0.5. So 0.5 milli equivalent of NaOH is left unreacted. So what happens that the pH of the resulting solution will be greater than 7. Okay, because 0.5 milliliter of NaOH is left unreacted, so therefore the pH will be, because the concentration of NaOH is greater in the solution. Okay, because 0.5 mole of it is milli equivalent of it is remain unreacted in the solution, therefore automatically the pH will rise. Okay, so it will be less than greater than 7, right? Greater than 7, option number 4. For question number 71, Given below are the half cell reactions. The half cell reactions are given. The E naught for 3Mn plus 2Mn plus 2Mn plus 3 will be. Okay. So for this we have to find, first we have to find which is the oxidation half cell and which is the reduction half cell. So from this, the value of E naught cell, we will find that this is the reduction half cell and this is the oxidation half cell. Okay. So similarly we have to find the value of E naught cell. So for E naught cell, what is the formula? E naught of reduction minus E naught of oxidation. The reduction half cell, the value of reduction half cell is given as minus 1.818 volt, and the value of E naught for oxidation is given as 1.51 volt. Okay, 1.51 volts. So this comes out to be minus 2.69 volt. So this comes out to be minus 2.69. So minus 2.69 is the correct option for E naught cell. And what else it is asked, that whether the reaction will occur or not occur. Okay, so this reaction is not possible as the delta G will come out to be positive in case, and that indicates the, so delta G for this reaction is positive. So if it is positive, what we will know, we will get that it is a non-spontaneous reaction and the reaction will not occur in this case. Okay, option number 3 is the correct option. Next is question number 72. Question number 72 says the phenol on treatment with aqueous NaOH gives an intermediate A, which on further reaction with methyl chloride gives B. Identify the product obtained after B is treated with excess of methyl chloride and the presence of anhydrous AlCl3. Okay, so let's see. This is phenol on treatment with aqueous NaOH. It gives an intermediate A. So first we will draw this type of mind map. Okay, this type of road map we will draw, which on further reaction with methyl chloride. Methyl chloride is CH3Cl gives B. Okay, identify the product B obtained after B is treated with excess of methyl. Then again it is said that excess of methyl chloride is used. Okay, and we will get a product C, or let it be B, but this product we have to find. This we have to find. Okay. So phenol on treatment with NaOH, aqueous NaOH, what it will get? It will get a intermediate which is known as the what? Phenoxide ion. Okay, this is the phenoxide ion which on treatment with CH3Cl. CH3Cl is the methyl chloride. So on reaction with methyl chloride, what happens? That this CH3 will get attached to the oxygen O minus here. Okay, this. Then what happens, if excess of methyl chloride is used, it will form OCH3 and the CH3 will get attached to the ortho and the para, both the ortho and the para position of this molecule. Okay, so this type of structure we will get. So which is the correct option? Option number 4 is the correct option for this question. Next is question number 73. For question number 73, in which of the following pairs both the species are not isostructural? Okay, so isostructural, what does isostructural means? It means having same shape and hybridization, right? Isostructural species are those species which have the same shape and same hybridization. So here see SiCl4 and PCl5. First option is SiCl4 and PCl5. So these both have the central atom with sp3 hybridization. So sp3 hybridization is same. Okay, here it is given these are not isostructural. So don't forget the not in the question. Which of these is not isostructural, we have to find out. So for first one, the hybridization is same for both of them. Okay, and they both have a trigonal bipyramidal shape. So these are isostructural. Option 1 will be incorrect. Second is diamond and silicon carbide. So diamond and silicon carbide both have giant covalent structure and they have tetrahedral arrangement. Okay, So these are also isostructural and the incorrect option. Third is NS3 and PS3. So NS3 and PS3 both have central atom sp3 hybridization and a trigonal pyramidal shape. So these both are also isostructural and therefore the incorrect option. Next is XCF4 and XCO4. So see, XCF4, it has sp3d2 hybridization and a square planar shape, while XCO4 have sp3 hybridization and a tetrahedral shape. So these both have different shapes and different hybridization, and therefore they are not isostructural. So it will be the correct option, right? Yeah. So next is question number 74. For the given reaction, identify the product A. We have to identify the product A. So this is the molecule, and on reaction with NEI and dry acetone, what happens? It will form it will give an SN2 substitution reaction. Okay, SN2 substitution reaction. So what happens that here iodine is reacted with this and the chlorine gets substituted. Okay, the chlorine gets substituted with iodine, and also what happens that there is a inversion of configuration. Inversion of configuration is observed, which means that iodine, which is supposed to be here, will interchange its position with hydrogen. Okay, hydrogen will come here, hydrogen will come from left to right, and iodine will come from right to left. Clear? So for question number 74, the correct answer will be option number 3. See, inversion is there. Don't forget about the inversion. Otherwise, you will tick the option number 1. So this will not the correct option. Option number 3 is the correct option here. Okay. Now question number 75. Silicate among the following has one oxygen atom of SiO4 shared with the next unit. Okay. Uh, Yeah. Silicate among the following has only one oxygen atom of SiO4 whole 4 shared with the next unit. So we have to identify the next unit. Okay. So let's see. Sheet silicate. So what happens in sheet silicate? Each tetrahedron shares 3 oxygen atoms with neighboring tetrahedra, forming a sheet-like structure. This means that the tetrahedron shares more than one oxygen atom with the next unit. Therefore, this option is not correct. Okay, sheet structure is not correct. Next is pyrosilicate. So pyrosilicate, what does it does? Pyrosilicates are formed when two tetrahedra share one oxygen atom between them. Okay. Yeah. So okay, in the question it is asked that which of these share one oxygen atom. So yes, pyrosilicates share one oxygen atom between them. So option number 2, pyrosilicate, will be the correct option. Three-dimension silicate shares 4 oxygen atoms, so this will be incorrect. And the linear chain silicate, okay, the linear chain silicate shares 2 oxygen atom. Okay, yeah, so it will also be incorrect. So the one which shares one oxygen atom is pyrosilicate. Okay, pyrosilicate will be the correct option. Next is question number 76. Yeah, for question number 76, identify the incorrect statement. Identify the incorrect statement for the given reaction. So let's read the statement first. This nitrobenzene on reaction with SnCl2. This is the reduction. Okay, SnHCl or FeHCl, and we will get a product X. So what will be the product? The product will be aniline. And we have to find out that which is more suitable, SnHCl or FeHCl. So let's see. So both will carry out the reaction, okay, but we have to see that which is more preferable. So here FeHCl is more preferable. Why? Because iron chloride formed after the reaction hydrolyzes further to give HCl. Okay, so the byproduct will be iron chloride. Okay, but what happens that it hydrolyzes to form the HCl. So as a result, what happens? Less amount of HCl is required for the reaction because some of it is already hydrolyzed, right? So the reaction will always carry on further. So option number 2 will be the correct option. Question number 77. At certain pressure, a 5.12% solution of a cane sugar is isotonic with 0.9% solution of an unknown solute. What will be the molar mass of the solute? We have to find the molar mass. So, okay, solutions having the same osmotic pressure are called isotonic solution. So, what are isotonic solution? We know that these have the same osmotic pressure. So, first find out the formula for osmotic pressure. Osmotic pressure equals to mRT. Okay, m is the molecular mass and R is the gas constant, T is the temperature. So, here it is given that both of these have the both of these are isotonic. Okay, so we know that for an isotonic solution, what happens that the both of these solution will have the same osmotic pressure. So osmotic pressure of cane sugar is equal to the osmotic pressure of the unknown solute. So here see, percentage of cane sugar by its molecular weight equals to percentage of unknown solute by its molecular weight. So percentage of cane sugar is given as 5.12, okay, and its molecular weight is 342, and the percentage of unknown solute is given as 0.9, and we have to find its molecular weight. So by this formula, its molecular weight comes out to be 60 gram. So option 1 is the correct option. Okay. So next is question number 78. Yeah. So below are the successive ionization energies of an element expressed in kilojoule per mole. So for E1 it's 577, E2 is 1820, E3 is 2470, E4 is 11,600 and E5 is 1,48,000 14,800. Okay. So what is its electronic configuration of the particular element? We have to find the electronic configuration. So here see, here it is slight increase and here for up to 83 it is slight increase in the ionization energies. But what happens after what happens at E4? E4 there is a suddenly there is a very much increase in the ionization energy is observed. Okay, so for the removal of fourth large electron energy, for the removal of fourth electron, large energy is required. So large energy required for the removal of fourth electron. So its electronic configuration will comes out to be 3s2 and 3p1. Okay, 3s2 and 3p1. So last electron to leave, much larger ionization energy is required. Therefore, option number 2 will be the correct option, 3s2 and 3p1. Okay. Yeah. So for question number 79, next is question number 79. Which of the following statement about the alkaline earth metals is accurate? So for alkaline earth metals, let's read the statement. The hydration energy of Sr plus 2 is greater than that of Be plus 2. Yes, the hydration energy is greater for Be. Okay, accurate it is asked. Okay, accurate, which means which is the correct option we have to find. So size of Be plus 2 is less than size of Sr plus 2, which means that hydration of Be plus 2 is greater. But in the option it is written that it is less than Sr plus 2. This is the incorrect option. Then CaCO3 decomposes at very high temperature than BaCO4. Okay, yeah. So the CaCO3 and Ba. Okay, let's read this one. Hydration of strontium sulfate. Strontium sulfate is less soluble in water than calcium sulfate due to the differences in the ionic radii and charge densities. The larger size and lower charge density of strontium ions compared to calcium ions result in weaker electrostatic interaction with the sulfate ions, making SrSO4 less soluble in water. Additionally, higher lattice energy of SrSO4 also contributes to the lower solubility of. Okay. Yeah. So for this option number 4 is correct. Option number 4 is C and D. C and D is correct. Okay. C and D because Ba BaOH whole 2 is a stronger base than MgOH whole 2. Yes, it is correct. And SrSO4 is less soluble in water than CaSO4. Okay, this is also good. Yeah, this SrSO4 and CaSO4 is explained here as Sr plus 2 and Ca 2 plus. Okay, these have the differences in the ionic radii and charge densities. So larger the size, lower is the charge density. Sr plus 2 has larger size and its charge density is lower. Therefore, it will be it will be less soluble. SrSO4 is less soluble than CaSO4. Okay. For question number 80, Na2 gaseous plus 3H2 gaseous will give 2 NH3 gaseous. In this reaction given above, the addition of small amount of inert gases at constant pressure will shift the equilibrium towards which side. So we have to find out when we add a small amount of inert gas. Okay, when an inert gas is added, what will be the effect at the equilibrium? So if an inert gas is added at constant pressure, it will result in the increase of volume. Due to this, equilibrium shifts to the direction where number of gaseous moles are more. Okay, so the equilibrium will shift towards the left hand side. Why? Because NH2 plus 3H2, it has more number of moles. The equilibrium will shift to the sides where the number of moles are greater. Okay, if so this side has greater number of moles than this side. Okay. In the given sequence of reaction, identify Z. Question number 81. Question number 81. We have to identify the Z. So let's see the reaction. Okay, here it is an aldehyde group. Aldehyde group on reaction with NaBH4. What happens that it reduces aldehyde to alcohol. So alcohol is there. Then when HCl is again added, it results in the substitution reaction. It results in the substitution reaction. So hydroxyl group, OH group is reduced to Cl. Okay, then KCN is added, then Cn is attached here. Okay, sorry. KCN is added, then what happens that carboxylic group is attached here. Carboxylic group is formed. So option number 1. Option number 1 will be the Z. Okay. Question number 82. Which is the following complex will have the 4 different isomer? So we have to find out which of the following complex has 4 different isomer. Option number 2. Option number 2 will have the 4 different isomer. You can also draw other options, but the question number 4 have the option number second has the 4 different isomers. Okay, so 2 are geometrical isomers and 2 are optical isomers. So let's see here, NH2 NH2, this is the cis form, and NH2 NH2 both are trans to each other, and here the Cl Cl are trans to each other. Okay, then optical isomers are there. So here these 2 are cis to each other and these 2 are cis to each other, and here it is the D form of this compound, of this isomer. Okay, let's read the next part. Question number 83. Distribution of hybrid orbitals in space. Distribution of hybrid orbitals in space. We have to distribute this. Okay, select the correct option. Like it is a matching type. It is a matching type. So here we can see that the table is drawn properly. Coordination number 4. For coordination number 4, the hybridization is sp3 and its geometry is tetrahedral. For coordination number 4, the hybridization can also be dsp2 and it is geometry is square planar. Okay. Coordination number 5, its hybridization is sp3d and its geometry is trigonal bipyramidal. For coordination number 6, its hybridization is d2sp3 and geometry is octahedral. So answer is option number 3. Okay. Yeah. For question number 84, identify the product C for the given sequence. We have to identify the product C. Yeah. So benzene on reaction with chlorine and iron and heating, we will get chlorobenzene. Then again when conc HNO3 is added, we will get this molecule. Okay, paranitro-chlorobenzene. It is the major compound which on reaction with NaOH, the OH is substituted here and this compound we will form. So the correct option is option number 2. Yeah, option number 2 is formed as the major product, which is the C. Okay. Here we can read also, after chlorination, the benzene ring undergoes nitration. So chlorination happens, nitration happens, and then as the chloride group is orthoparadirecting, so further reaction will causes the substitution of Cl by OH. Okay. Question number 85. The vapor density of the undecomposed N2O4 is 46. When heated, the vapor density decreases to 24.5 due to its dissociation with NO2. The percentage of dissociation of N2O4 at the final temperature. Okay, we have to find the percentage of dissociation of N2O4. So we know that N2O4 reversible will give 2NO2, and we know that vapor density of N2O4, capital D is the vapor density of N2O4 before dissociation by vapor density of mixture after dissociation. It is 1 by 1 plus N minus 1 alpha. Okay, on putting all these values from the question, we will find that alpha comes out to be 0.4674. Okay, so what happens, that the degree of dissociation will be 46.74. Okay, 46.74, which means that answer is 3. 46.74 we can round off it as 47%. Okay, so we have moved to our next section, which is section B. Okay, section B, question number 86. The ion which have the maximum magnetic moment. So magnetic moment, we know that how the magnetic moment is calculated by the number of unpaired electrons, right? So the maximum magnetic moment is the one element which have the largest number of unpaired electrons. Okay, so for Mn2 plus, the unpaired electrons is 5. Okay, for Fe plus 2, the unpaired electrons is 4. For Ti plus 2, it has unpaired electrons of 2. Okay, so from this we can say that uh, the Mn has the maximum number of unpaired electrons. Okay, so Mn has the maximum number of electrons, unpaired electrons, which is 5. So it will have the magnetic moment. It will have the highest magnetic moment. Question number 87. Which reaction indicate the acidic nature of the amino group? Okay, so we can find that the acidic nature of the amino group can be identified by, answer is 2. This reaction. How? The acidic nature of the amino group is demonstrated when it reacts with a strong base to form a salt. Okay, so amino group is acidic in nature, and when we react it with a strong base, it forms a salt. So option 2, here amino group is there and Na is there. So we will find this as this is the salt and H2 is released. Okay, amino group reacts with sodium to form a corresponding sodium salt, which indicates the presence of acidic hydrogen atom in the amino group. This process involves the transfer of proton. Okay, this is there. So next is question number 88. In question number 88, the rate constant for the reaction is given as 10 to the power minus 3 second inverse. Then time for the completion of 75% reaction. So A is 100, let A is 100 and A minus X. Yeah, X is 75. So A minus X is 100 minus 75, which comes out to be 25, right? So we have to find out the time. So T is equals to 2.303 by R. T is equals to 2.303 by R log of A by A minus X. Okay, on putting all these values, we will get T is equals to 1386.4 second. 1386. Okay, second option is the correct option. Next is question number 89. What is the correct order of spin only magnetic moment? Spin only magnetic moment we have to find. So for this also we have to find the number of unpaired electrons. So let us find the number of unpaired electron first. So Mn plus 2 has 5 unpaired electrons. Cl plus 2 have 4 unpaired electrons. V plus 2 have 3 unpaired electrons. Okay, So since mu is equals to under root n plus 2, this is the magnetic moment formula. Okay, that is it increases with increase in the number of electrons present in the species. So the magnetic moment increases with the number of unpaired electrons. The greatest number of unpaired electron is there is in Mn plus 2. So Mn plus 2 has the greatest, then Cr plus 2, then V plus 2. Option number 3. Question number 90. Next is question number 90. Which of the following given reaction is correct? Okay, so we can see here. So the product of first one is this, which is incorrect. The product of second one is this, which is also incorrect. Third one is also incorrect, and the fourth one is the correct reaction. Okay, option number 4 is the correct option. Question number 91. Question number 91 says that according to second law of thermodynamics, a process is spontaneous if during the process, so for a process to be spontaneous, the delta S universe should be greater. Okay, delta S increases, then only the reaction is spontaneous, which means delta S universe should be greater than 0. Okay, should be greater than 0, then only the reaction will be spontaneous. Question number 92. Yeah. For question number 92, at 298 Kelvin, it is a numerical type question. At 298 Kelvin, 500 centimeter cube of H2O dissolve in 15.30 centimeter cube CH4 under a partial pressure of methane of 1 atm. If Henry's law holds, what pressure is required to cause 0.001 mole of methane to dissolve in 300 centimeter of water? Okay, so this is the question. Yeah, so here see which is the correct option of okay, so we know that 15.03 centimeter cube of CH4 is dissolved in 500 centimeter of water. So we have to find the volume we dissolve in 1 centimeter of water. Okay, so for 1 centimeter of water, what we have to do, 15.30 by 500 into 1, so it comes out to be 0.03006 centimeter. Amount of gas dissolved will be PV is equals to RT, PV by RT. Okay, so from this we will get the amount of gas dissolved. Then mass of gas dissolved also we have to calculate. So amount of gas dissolved into the mass, into mass. So this comes out to be 2.14, and according to Henry's law we know that M is equals to Kp. So substituting the values of M and P, we will get K is equals to this much. Okay, now so for 1 into 10 to the power minus 3 mole of gas in 300 centimeter cube of water, we have mass of gas dissolved in 1 centimeter of water, which comes out to be 5.30 into 10 to the power minus 5 gram. And for Henry's law, we know that the pressure required to dissolve in the above amount is M by K. Okay, so for this we can find out the pressure, which comes out to be 2.486 atm. Okay, 2.486 atm. 2.486 atm, which is equivalent or nearer to 2.33 atm. Right? Okay. The next question is question number 93. Identify the product Z. We have to identify the product Z. This is the ketone on reaction with NaOCl. It will give sodium phenoxide. Then on reaction with CHCl3, this type of compound is formed. It is isocyanide. Okay, you can't see now. This is isocyanide. Okay, isocyanide. So Z, which is the correct option for Z? Option number 4, right? Option number 4 is the correct option. Next is question number 94. The time for a half-life period of a certain reaction A tends to product in 1 hour when the initial concentration for the reaction A is given 2.0 into mole per liter. How much time does it take for the reaction to come from 0.50 to 0.25 mole if it is a zero order reaction? Okay. So for zero order reaction, we know that R is directly proportional to H, and from this formula AT is equals to A naught by KT, we can find out the value for K. Okay, so value for K. So here the value for K comes out to be 0.25. So we have to only put the values in the formula for zero order reaction. Next is question number 95. The formula mass for more salt is given as 392. The iron present in it is oxidized by KMnO4 in acidic medium. The equivalent mass of more salt. We have to find the equivalent mass of more salt. So more salt, we know that this formula, more salt has a formula of FeSO4.NH4 whole 2 SO4.6H2. Fe plus 2 present is in it is as the oxidized form, and it is oxidized to Fe plus 3, okay, in more salt. So we have Fe plus 2, it is oxidized to Fe plus 3, okay, it is oxidized here. Thus equivalent mass is formula mass by 1, which is 392. 392 is the correct answer. Okay. The amount of halogen in a certain organic compound. Question number 96 we are going to solve. The amount of halogen in a certain organic compound was estimated during the Caris method. If 0.15 gram of organic compound will give 0.12 gram of AgBr, what is the percentage of bromine in the compound? We have to find out the percentage of bromine. Okay. So for Caris method, we know that the mass of bromine, okay, mass of bromine, what is the mass of bromine? It is 18 U. Then mass of AgBr, mass of AgBr is 188 U. Then weight of AgBr, it is given that weight of AgBr is 0.12 gram. Okay, here it is given 0.12. Then again weight of organic compound is also given as 0.15 gram. So we have to find out the percentage of bromine, right? Okay, here. So the percentage of bromine is the molar mass of Br by molar mass of AgBr. Molar mass of Br by molar mass of AgBr into weight of AgBr by weight of organic compound. Okay, from this we can find out the percentage of bromine. So molar mass of bromine is 80 and molar mass of AgBr is 188. Then weight of AgBr given as 1.02 and weight of organic compound is 0.15. So upon this comes out to be 34.04%. So option number 1 is the correct answer. Like this we can calculate the percentage of bromine, right? Question number 97. Okay, question number 97. A colorless gas which burns with blue flame and reduces copper oxide to copper. Okay, so it is hydrogen gas. Okay, hydrogen gas, it burns with blue flame, and when hydrogen gas is burned in air, it produces a clean and nearly visible flame with a pale blue color. Okay, so hydrogen gas is burns with blue flame and it also reduces copper oxide to copper. Okay, for this reaction we can see there it reduces copper oxide to copper. So hydrogen gas is the correct answer. Question number 98. The oxidation state of phosphorus is minimum in. So we have to find the oxidation state of phosphorus in all these. Okay. So in phosphine, the phosphorus atom has a -3 oxidation state. Okay. And in all other compounds, the phosphorus has a positive oxidation state. All of these has the positive oxidation state, and in phosphine only there is negative. So this will have the minimum oxidation state. Option number 3 will be the correct option. Next is question number 99. Which titration among the following option is feasible when phenolphthalein is used as an indicator? Okay, so when phenolphthalein is used as an indicator, the titration of oxalic acid with sodium hydroxide is feasible. Option number 2 is feasible. Why? Because as the indicator, because the pH at the equivalent point falls with the indicator pH range of 8.2 to 10. So what happens at equivalence point? The solution become basic due to the complete neutralization of oxalic acid by sodium hydroxide, causing phenolphthalein to change from colorless to pink or red. Okay, yeah. So titration of phenolphthalein, titration of oxalic acid and sodium hydroxide with phenolphthalein is feasible. Now, then last question, which is the question number 100. A gaseous mixture contains oxygen and nitrogen gas in the ratio 1:7 by weight. Therefore, the ratio of the number of molecules, we have to find the ratio of number of molecules. So, we know that the gaseous mixture contains oxygen and nitrogen gas in the ratio 1/7. So, let us assume that the mixture contains 1 gram of oxygen and 7 gram of nitrogen. Okay, so on calculating these, what happens at the ratio of molecules? Okay, we know that the number of molecules of oxygen is equals to number of mass of oxygen by molar mass. Also, the nitrogen is also mass of nitrogen and molar mass of nitrogen. Okay, so we know the molar mass of oxygen and nitrogen. So number of moles comes out to be 1:32 and 1:4. So upon taking the ratio of all these, it comes out to be 1:8. Option number 2, 1:8 is the correct option. Okay. So yeah, keep learning. Thank you.